In Lesson 5, we ended with a stub page for creating new users. Over the course of the next 5 lessons, we'll fulfill the promise implicit in this incipient sign-up page. In this lesson, we create a data model for users of our site, together with a way to store that data. Along the way, we'll learn more about active record validations, including email format validations using regular expressions. We then use hasSecurePassword and the bcrypt library to add secure passwords to the user model. We ended the last lesson with a stub page for creating new users. In this lesson, we'll take the first step toward turning that stub into a working sign-up form by creating a data model for such users, together with a way to store that data. In the following lessons, lessons 7 through 10, we'll build on this foundation to develop a full Rails login and authentication system. Before getting started, I want to do a little cleanup. Let's take a look at what our current state is. I want to run the server. Binding IP and the port. And while that's starting up, let me just show you one of the issues we're dealing with. Sometimes the Cloud IDE can get a little sluggish. This won't apply to you if you're not using Cloud9, but this is something that I run into sometimes. When the tests are running inside of Guard, it starts up a Spring server, as I've mentioned before. This is a server that preloads some of the Rails environment to speed things up. But these things can hang around, these Spring processes, and slow things down. So I'm going to list all the processes and then grep for Spring. You can see that there are some of these really old things 141 hours ago. So I'm going to kill those. bkill -9. That's the kill code in Unix. And then I'm going to give it the -f. I'm actually not sure what -f stands for, but it's going to be Spring. So it's going to kill those. And if I run this process and then through the grep Spring, you can see that that works. So start up Guard. Actually, I want to do bundle exec. Let's see, our web server should be running, so let's take a look at that. Alright, and we actually linked this, right? There we go. So this is our little stub for the sign-up page. What we want to do is turn this into an actual sign-up page that lets people register for the new site. Let's take a look at a mock-up of that. So this is a mock-up of the sign-up page where we have fields for name, email, password, and a password confirmation, and then a button to create the account. So this is our goal. We want to get to a working sign-up form. And this is a lot harder than it looks. If you were to ask an experienced web developer, how hard is this? They would probably say, oh, that's not that hard. No, this is a really hard thing to get working. In fact, we're going to take this entire lesson just building the back end to store the data that gets submitted by a form like this. So let's get started by creating a new Git branch. For modeling users. Let's take a look at a diagram to get a sense of what we think our users table might look like once it's working. You can see here that we've got a users table. It's a plural, that's the convention used by Rails. And there are 3 columns. There's ID, name, and email address. So the ID is just a unique way of identifying each user, in this case just an integer. And then there's the name and the email address, which we'll also be using as the username. So this table corresponds to the following users model. This is also the users table, but in this case, I'm just representing it in a slightly different way. These are the 3 columns, ID, name, and email, which in this case, we're really thinking of as attributes on an object. And then here are the types. There's an integer type for the ID, and then the name and email are both strings. Now let's translate this diagram into code. Do that with the migration. You may recall that we generated a user's controller like this, and we gave it an action name because we wanted a new page. In this case, instead of putting the action, we'll actually put the attributes, but I'll put that in just a second. So we've got a user model. This is the convention in Rails to use a singular. And so instead of Rails generate controller users, we have Rails generate model user. And then we can put the attributes on the command line, and the name will be a string. You can see we can give it the type as well. And the email address, which we'll just call email, is also a string. So this will generate a file for us called a migration that will let us update our database. You can see the migration file name here includes a timestamp. This will differ on your system because presumably you're making this at a different time. In fact, I can pretty much prove it. But the name here is the same on all systems. The reason for this timestamp is essentially so that people on different systems, like different collaborators, can create migrations and have them not conflict. Like in older versions of Rails, this used to be sequentially numbered, like 1, 2, 3, and that would cause conflicts if people made migrations on two different systems and then tried to merge them. So this is just a way of avoiding clashes. So let's take a look at it. It's in, well actually let's just collapse these guys. Look at, it's what you can see here, db migrate is the folder, so db migrate, and there it is. If it's not there, you should go up to here and go to refresh file tree. And here it is. This is not important to understand in detail. This is just something generated by Rails. The thing to focus on is this section in here, this t.string name, t.string email. So as you can probably guess, this is the type, and these are the attributes. T here is a variable that is passed to a block. You can see that create tables users do. This is a symbol. This is a block. This T just stands for table. So this is a table object, and it's not important to know how it works. I don't know how it works. This is just something that we can use inside this block here to create new attributes on the table. In this case, name and email. And then you can see this line here, t.timestamps and then null false. This is just a way of telling the database that these things should not be empty. They should not be null, which is the database way of saying nil, essentially. And we'll see in a moment what t.timestamps gives us. In fact, let's take a look at the diagram right now. So this is our sketch, what we thought this user's data model might look like, but here's what it actually looks like. So here we've got the ID, name and email, which we expected, but then it also has these two columns, created at and updated at. These are the columns created by this. This line, t.timestamps, automatically creates these columns. We do not ever have to manipulate these columns, at least not in a regular application. We'll see later on in this tutorial we actually will manipulate, I think, the created at in the context of a test. But these are automatically updated by Rails. They're usually called magic columns. And that's because they just get updated automatically. When you create a new user, it stamps the date time here. And then if you change that user record, then it changes updated at. By the way, you might also have noticed that here we did not include the ID among the attributes, and that's because Rails includes it automatically. We can update our database with the information in this diagram that was created by this migration, or this migration file rather, by actually running the migration. Do bundle exec, we use rake, and then it's rake db migrate, the colon there. We saw this before in lesson 2, but now we're actually digging into it to try to understand what's going on. Alright, let's take a look at what that did. We can actually look at the schema for the system. Actually, where is that? It's in sample app db schema, so it's in here, db. It's weird, so it's not appearing, that's why I was confused. Refresh it. There it is. This is a file that actually has the data model. This is just a recapitulation here of the migration, essentially, except it's got a little bit more explicit information. So t.string. You can also see a tiny difference. This is a string instead of a symbol, but you shouldn't worry about those things. So this file contains the most up-to-date version of the data model. Let me show you how to reverse this thing if you want to. If for any reason you want to undo one of these migrations, if you did something wrong, for example, in terms of your data modeling, you can do a bundle exec rake db rollback. You can see here that the schema.rb file updated. So let's rerun that migration, though. We actually want to do it. All right, you might be wondering, what exactly is this doing? I mean, so this is updating the schema file, but somewhere information must be persisted, right? We must be storing data somewhere in some database. And the answer is that in development, we're using a database called SQLite. So this is, in fact, an SQLite file. So if I just double-clicked on it, you can see that it's not very helpful just looking at it as a plain text file. The only thing that's really readable is this thing at the top, SQLite format 3. But we can actually take a look at this by downloading it to the local machine. I'm going to right-click on it. You can also control-click. And see, I'm going to download it. And you can see development paren1 here. So development is the name of the database. It's development.sqlite3 because it's our development database. And this 1 indicates that I've already downloaded it once into this directory. But that's okay. It's just there to disambiguate it from the previous download. I can save it here. And let me go to a local terminal window. And now I'm just going to make a directory for the databases for the sample app. And let me cd there. And I'm going to move that development database from the downloads to here. Let's escape these out. There we go. And let me just call it development. Ah. There we go. So I just want to take a look at that. Let's open it up. On OS 10, this open command will open this with whatever the program is associated with this. So let's open it like this. And you can see this is the database browser, the SQLite database browser. You can find a download page for this in the Rails tutorial book, or you can just Google it. And if you look at this, you can see, in fact, that we've got all the structure that we put into this, this model. If we look over here, you can see ID, name, email, created at, updated at. This is an actual database now, though. This is looking at the local SQLite database. SQLite is actually a production-ready database for things like embedded applications, but you wouldn't ordinarily use it for a web application. And in fact, we'll be using PostgreSQL in production. If you're looking for a very challenging exercise, you can try installing PostgreSQL on your local machine. There's a footnote in the book giving you some direction on how to do that. But it's so much easier just to deal with these SQLite databases that we'll be using them in this tutorial. So an SQLite database, in fact, is just a file. There's no extra structure. It just lives in a single file. And you can see here that it's got all of the attributes that we wanted. By the way, in case you don't know how to associate a program with a particular kind of file, let me show you. This is actually pretty tricky. This is really quick. I'm going to do open dot to open up the current directory using the Finder, which is the default application for directories. So if you right-click on this and go to, let's see, it's get info, and then you change this. You go to open with, and you choose whatever you want, and then you click on change all. So that associates SQLite browser, in this case, with the file name extension SQLite3. That first step of clicking on get info seems quite counterintuitive to me, so I mentioned it for completeness. One of the things our Rails generate model did was generate an actual model file. So let's take a look at it. This is an app models user.rb. And you can see that it's really quite compact. It's just basically one line. There's end, but this is the only line with any real content. Class user, but then it inherits from active record base. And as we've talked about briefly before, this is inheritance. And as a result of this line, everything in active record base, which has a whole bunch of different things for manipulating and talking to databases, automatically gets inherited by the user model. To get an idea of the kinds of things that we get by inheriting from Active Record Base, let's take a look at some concrete examples. Because we don't have a web interface yet to deal with users, most of this lesson will involve interacting with the user model through the Rails console. And at this point, I don't actually want to change the database, but we'll be doing things like saving users that ordinarily would change the database. So what I'm going to do here is start the console in a sandbox. This is a common term in computing. A sandbox means that anything we do is temporary, and what will happen in the case of the Rails console is that when we leave it, it will roll back any changes we make. One of the things we get from inheriting from Active Record Base is a constructor for new users. So let's do user.new. You can see this here. This user has attributes corresponding to these database attributes here. ID, name, email, created at, updated at. You can see those here. But of course, they're all nil initially because the constructor was just user.new. We didn't give it any information. But instead of just calling new, we can actually give it an initialization hash. So let's take a look at how that works. And actually, when it was assign this to a variable, so user equals user.new, and then I'm going to give it key value pairs. Remember that I can do something like this. This gets converted to a symbol. This isn't a symbol per se, but this is converted to the symbol name with value of a string, Michael Hartle. And again, the key here is email. And notice that I don't have key value pairs for ID, created at, or updated at. Those are handled automatically by Rails. So let's take a look at this. You can see that we've now got our name and email right in here, but the other attributes are nil, so we can do this. Let's just go down the list. User.id is nil. User.name is what I said it was going to be. This is also the value I wanted. Created. Actually, let's see what this will give me an error, right? You can see no method error. So let's fix that. Created at and updated at. Actually, doesn't matter. So those are nil. And it's important to understand at this point that we've only created this user in memory. This user exists in our console session, but it has not yet been persisted to the database. So let's actually do that, and we'll see that these ID, created at, and updated at columns get changed automatically by Rails. The way to do that is with the save command, and we can actually get a hint of whether this is going to work by seeing if this user is valid. So this user is valid. This valid question mark Boolean tells us essentially if we try to save this user, will it work? So let's actually do it with the save command. These are the kinds of methods we get by inheriting from Active Record Base. So user.save. You might notice here that the console has output the SQL, or structured query language, actually used to insert the record into the database. You can actually learn a lot about SQL just by reading these messages, but that won't be important for this tutorial. What is important is this return value, true. That indicates that the save succeeded. If it fails, as it will when we add data validations later in this lesson, then user.save returns false. Let's take a look at the effect of that save on the user variable. You can see now that the ID, which before was nil, is now 1, and these created at and updated at columns have also been set automatically. So we can do something like this. User.id and the user.name and email are the same. We can do this. Created at and updated at. Later in this lesson, we'll see that when we change the values of this user in the database, this updated at column will automatically change, but created at will not. this is the permanent record of when the object was first saved to the database. Active record includes a nice compact way of combining new and save into a single step. Let's see how that works. So user, here is the user model, user.create, and then I'll give it the same kind of initialization hash with name and email. Oops, I want to capitalize this. Doesn't matter, of course. Another user, and then do that, and I'm just going to make a third one. Call it foo. I'm going to assign this to a variable because I'm about to do something else with this variable. So that's a second user, or actually a third user, the second user created using user.create. You can see from the SQL that's being output that this is being inserted into the database. One thing you might note is that the create method actually returns the object created by the database. So that means that foo here is actually the user created by this line. And so we can do things like this. This works just fine. And if we want to, we can also destroy this record in the database. So this is the complement to create. We're going to do foo.destroy. Now, if you look at the foo variable, it still exists just the way it was before, because this is the variable in memory. So to confirm that foo was actually deleted from the database, we need to learn how to actually find user objects in the database, and in this case, verify that foo doesn't exist. So let's learn how to find user objects. One way to do it is using the find method. And in this case, we can give it an ID if we want to, just user.find of 1. You can see that that actually finds the user record right here, returns it. Let's give it an ID that we definitely know doesn't exist. Let's just say find of 100. So you can see in that case, find returns an error. It's an active record, record not found error. Couldn't find user with ID equals 100. So remember what foo is. Here's foo. Foo.id is 3. So let's do this. User.find of 3. This should return that same error. I guess it should raise that same error. It's good. So this means that that user doesn't exist. In fact, we could even be more abstract here. We could do user.find of foo.id. This should give us the same error. This is pretty noisy, so you can actually use a second method called user.findBy. See here, this will actually just return nil if it doesn't exist. That's weird. What happened there? That is not at all what I expected. That's really strange. That's a bug. Oh, no, it's not. It's a bug in my thinking. So find by, this is instructive. It actually did something useful here. So what it's doing here for some reason is it's just returning the first record. Oh, I see what's going on. So we can actually debug this by looking at the SQL. Select users.star from users where 3. So I believe this is just true. So what it's doing is it's saying, well, just return a bunch of users, limit 1. So that means return only one user. And what it's doing is just returning the first user in the database. So find by does not work the same way as find. So user.find of 3 gives us that error, right? But user.find by, we actually have to say what we're finding by, in this case, the ID. So if we do find by ID 3, that gives us this, this nil. That means the user doesn't exist, so that confirms what we were hoping for. And of course we can do this too. We can do ID is 1, and that should pull out the first user. There we go. By the way, there's no guarantee that this 1 is actually the first user. This ID could be anything, so you should never rely on that. If you need the first user, you can do something like this. User.first. Even this is a little dangerous because we haven't specified in this model what the ordering is. But we'll see in lesson 11 how to impose an actual ordering so that we can guarantee that user.first, or in that case micropost.first, will return the right value. This user.findById is potentially useful if we want to find a user that might or might not exist and we don't want to deal with that exception. But there's another way to find users by an attribute using the email, and this is actually the most important way for our purposes. I'm going to find by the email address, and this is actually how we're going to log users in. When users try to log in, they'll submit their email address and password, and so we're going to find them using their email address and then see if the password matches. We saw up here that we can pull out the first user in the database. There's another method for returning all the users. That's just user.all. We actually saw this briefly in lesson 2. We can also see here by inspection that user 3, the foo user, in fact does not appear in the list. Yet more confirmation that foo.destroy actually did what we wanted it to do. We see now how to create user objects, but it's often important to be able to update them as well. So let's just verify that we've got a user variable. There it is. So let's see how to change the email address. You can just use the assignment operator, which is equals, on the email attribute. And this is going to be, let's just do example.net. By the way, if you're wondering, where does this name, email, where do these come from? How does Rails know to use or to access user.email? Because there are no attributes in here. Like in the second lesson, we had an attr accessor here. We did this, something like this. So why don't we need that? And the answer is that Rails automatically knows that there are name and email attributes because they're columns in the database. So that's part of the magic of the library that Rails uses by default for talking to databases, ActiveRecord. So let's complete this assignment. This just changed the user in memory. This did not change the database, and we can actually confirm that like this. We can reload the user, and now actually there's just what you can see right here. It's still example.com. We wanted to change it to example.net. So let's try that again. Save it, and now it should be reloaded. There we go. So you can see that mhartle@example.net is the new email address. You might also note that reload actually returns the object, so you can do things like this, user.reload.email, to verify that it's right. And you can also use this to overwrite changes in memory. So we can do user.email equals, let's just say, foo@bar.com, and if we reload this user and then access the email address, it will just overwrite that change. So this happens in memory. This is just in the console. This is going to pull it out of the database. It's going to reload it from the database and then use email to grab the email attribute and return it, and there it is. So you can see that it actually just overwrote this. By the way, now that we've updated the user, we actually have a new updated at column. The user was created at this time and date, but updated at has been changed and is now different from created at. Often it's convenient to use a hash to update attributes rather than doing assignment. Let me show you how that works. This is the update attributes method. This is actually an alias for the update method. It's a little shorter. But as we'll see in a moment, there's actually an update attribute method as well. let's do this. Name the dude, email dude@abides.org. So that actually did the save. That actually changed the attribute in the database, as you can see from the SQL here. And it returns true because it worked. There's one final common way that we'll be using to update attributes, which is the thing I just mentioned. It's update attribute singular. And in this case, it's not a hash. It's actually the attribute name. In this case, I'm going to change the name. And then the second argument is the value. As we'll see later in this tutorial, one of the things that update attribute does that's different from doing an assignment and saving is that this does not run the validations. In fact, it skips a whole bunch of other things too. This essentially forces the database to use the new value, whether it's valid or not, or in particular whether the user object is valid or not. Now you might think that's a really bad idea, but this is important sometimes when, for example, to create or update a user using assignment, you would need a valid user, which would require you to know the user's password. But as we'll see later in this lesson, the passwords will be hashed in such a way that even the people running the site, in this case us, have no idea what the password is. So we need a way to be able to update the database even if the user object isn't valid. And the way we'll do that is with update attribute. So far we've been creating valid users, or rather users that will be valid as we move forward in the tutorial. Right, so this user has a name and email address that are actually valid formats. But right now we can also do something like this. Right, we could put in values that we wouldn't ordinarily accept, so blank name or an incomplete email address. So these are the sorts of things that we'd like to catch. Take a look at our model again. So let's think about the constraints we want to put on these values. ID, created at, and updated at, these are things set by Rails, so we have no control over those. But name and email we want to constrain somehow. So first of all, both should exist, right? Name and email should both be non-blank. We also should probably put some sort of constraint validation, like a length validation on this name, so that people can't submit, say, 10,000 character names. We also want to constrain the format of the email address, because email addresses do have this particular pattern that they generally match. And finally, because we're using email addresses as the login username for the site, these should be unique. So if we try to create a second user where the email address already exists in the database, that shouldn't work. This is exactly one of those cases where I particularly like to use test. This is exactly one of those cases where I particularly like to use test-driven development. I find it's really useful when making data models. So let's start by writing a basic test. This is under test, models, user test. And we can shut this down. I'm going to split this here. Actually, I want to do, let's do this here. There we go. And here I'm going to switch over to guard. So let's run our test suite. It's always good to make sure that we're green just to start off with. So this is the user test file generated by our Rails generate model. And since we're going to be validating these users based on things like blank values or the length of attributes, it's good to have a sanity check just to make sure that we can start off with a valid user. So let's get rid of this here. And I'm going to use the special setup area. I can do def tab. So this is a setup method. This may look familiar if you solved the exercises for chapter 3 in the Rails tutorial book. This setup method gets run before every test. So let me use it to create an instance variable. I'm going to want to use this variable in the different tests. And the way to do that is to define it with @user. And let's create a new user. I'm just going to create it in memory, and I'll save it if I need to. Save it to the test database. So that's a test user, and now I'm going to say test should be valid. And the way you might read this is a test user should be valid. I think I mentioned before that I'll sometimes use should and sometimes won't, depending on context. So in this case, I want to check that this user is valid. And the way to do that is to do, say, well, this is true if the user is valid. So let's do assert. Let's assert that that's true. You saw before when the generated test said assert true, we had this. So this will pass. Right. Just get rid of that. And so assert @user.valid should work. There we go. Okay. By the way, if you want to do this at the command line, you can do this. It's going to say rake, which should be bundle exec rake. And then you can do rake test models. So you can see that that passed. Right now there's only one test, but this is useful if you're just running the model tests. All right, now I want to write some validations for presence. So we're going to put these in here. We're going to do like validates presence, like this. We saw an example of this in lesson 2 briefly, but now we're going to be doing this for real. So, but I actually don't want to do that yet. I can save it, and it should still be green. So I'm going to get to red. This is the red-green cycle. Oops, I want to put it here. So let's say test. Name should be present. Do, and, well, how can we assert this? So let's do assert. We're going to do this. We want something like this. Assert not. So we can actually do this. We can do bang. This will work, or we can do this, assert not. This is probably the idiomatically correct way to do it. And let's see. What we want to do is make this user's name blank, or empty, or somehow invalid. User.name equals, so let's just use the empty string. Save that. This should be red. So now if we add this validation in, it should go green. Cool. It's probably a good idea to put some spaces in here, because it's actually not just the empty string. We actually want someone trying to register for the site with a blank name to get some sort of error message. So if we save this, this should still be correct. So let's just go red, and then go to green. Cool. So under the hood, what it's really doing is calling the blank method. This is added to Ruby by Rails. So a bunch of spaces is blank. But if you put something in there, now that's not blank. So let's take a look at some of the effects of creating this validation. So I just want to copy this and put it into our console here. So let's see if that user is valid. Notice I didn't copy the at part, that's because there's no reason to create an instance variable here. And generally speaking, if you don't need an instance variable, you should just use a normal variable. So this should be valid, right, because the name and email are present. But if I do something like this, let's do, just get rid of the example username and just put in spaces. So user.valid should be false. Oh, so this is a good little tip here. So what happened here is that the validations have not actually been imposed because this console session got started before we added this validates line. So let's see if we can get this to fix itself. I think we can maybe reload, or so that didn't work. Let's see, reload bang, I think. Let's see if this works. There we go. So that worked. So doing reload bang forced the console to reload the user model. By the way, if this sort of thing doesn't work, if you do reload bang and it's still not giving you the expected behavior, at that point you should probably just exit the console and restart it. It's a little heavy-handed, but it's the only way to be sure sometimes. So now that we've called user.valid question mark, Rails has actually done some error checking for us. In particular, there's now an errors, well, it's kind of an array. I'm not sure what it is. Actually, let's take a look at it. It's an active model errors. It basically acts like an array, though. And actually, that's not quite true. It's not really an array, but full messages is, though. So we can call full messages. This is a method on this errors object. And just pulls out the messages here. It actually converts. So this is a hash here. It converts that to an array, I think. Let's take a look. Yeah. So in this case, Rails is synthesizing error messages for us, and this will be useful in the next lesson when we're trying to give users some feedback if they try to sign up but it doesn't work. This will end up being an error message that gets displayed on the sign up page. And of course, if we try to save this user, it should say false, yeah. So that's because the user is not valid due to the blank name. All right, having added the validation for the presence of the name, it's easy to do the same thing for email. So let's just copy this. Email should be email. Same thing, assert not at user.valid. This should be false, so assert not should be true. Save this, it should be red. Let's go over here to guard. Good, it's red, and that's because we don't have the validation. So let's just copy this. It should be the same thing except email. I'd like to add a space here just to line everything up. And that should be green. Great. The next step is to add a length validation to the name. So let's make a test for that. Say the name should not be too long. And here we have to decide what the maximum length is. I think strings can hold 255 characters, but that's really long. We want shorter names so that we can fit them on our site layout. Like when we display names to the screen, I think 255 is too long. So I'm just going to pull a number out of thin air and say that 50 is going to be our upper bound. So let's make a user with a name of length 51 and then make sure it's not valid. Now this is kind of inconvenient to type out something that's exactly 51 characters long. So there's a trick I want to use, which is to use string multiplication. We have normal multiplications, like 3 times 2 is 6. But you can also multiply a string by an integer to make a string of that length. So this is a times, say, 5. You can see there, and so a times 51 is just a string of length 51. Do this. Actually, I think this will work. Should be 51. There we go. So let's just copy this and say the user's name is 51 A's long. It has length 51, and we want to say that that's not valid. Save that. It should be red. There we go. And now let's put the validation in. we're just going to add to the presence validation, we're going to say length. So this thing, by the way, this validates is just a method. I'll change it up in just a sec. I'll show you how it works. So this is length. Maximum is 50. So what's going on here is this validates is just a method, and its first argument is which attribute is being validated, and then this is a hash here. So we can actually just put these on to show you how it works. So it's still green, but idiomatically you would never do this. The reason we need this interior one is because otherwise it's ambiguous where the hash ends. So if we just did something like this, it probably gives me some sort of error message. Yeah. All right, so this is a syntax error, which is why we need to put in, the curly braces here. All right, there we go. You know, it just occurred to me that we should probably put a length validation on this email attribute as well, because we'll be validating the format, but that's not going to constrain the length. And because it's a string, I think it can't be any longer than 255 characters. So let's do that. And actually, let's do this with TDD. So let's comment this out. It should be green. And email should not be too long. And do 256 here. Should be red. There we go. And uncomment this over here. Should be green. Great. All right, now that we've validated the length of the name and the email address, we should also validate the format of the email. There's no perfect way to do this. There's actually a pattern that every email address is supposed to follow, but it actually allows crazy email addresses like this. Like this is a valid email address according to the standard. Like you can put spaces in the middle of it. It's just crazy. So what we're going to do is actually just require people to have a normal looking email address, which basically everyone does. We'll be using an especially simple variant. If you look at the exercises in chapter 6 of the Rails tutorial, you'll see a more complicated pattern that email addresses can match. But this is a pretty robust one that we're going to look at right now. We're going to be using a technique called regular expressions, which are really quite error prone. They're very complicated and a little tricky. So I'm going to write some tests for valid email addresses first. This is actually just kind of a check on the eventual pattern we're going to use. So let's start with this. I'm going to say email validation should accept valid addresses. And let's put in some valid email addresses. Remember this %w trick, except you have to type the w. This creates a string of, or an array of strings, so %w, like this. So I'm going to put in some email addresses here that should be valid. So user@example.com. It should be case insensitive. So this should also be valid. We should accept underscores and hyphens. I use This tests that we can accept multiple subdomains, or a subdomain here, foo.bar.org. That should be valid. And let's look at some other common cases. This is a very common sort of pattern. First.last at, and let's do foo.jp. This is the top level domain for Japan, but this just verifies that we can accept 2 instead of 3. This is just not really a proof, but this gives us a sense of the kinds of things we want to accept. This is also documentation. We also want to accept plus signs. This is valid. Alice plus Bob. at baz dot, let's do another 2-letter one, CN for China. And for each of these valid addresses, I want to assert that a user with that address is valid. So let's do that. Valid addresses, this is a case of iteration, so we're going to call the each method and give it a block with a single variable do and then the valid address. And then inside the block, we can call the assertion. So we need to do this. We need to do the same trick we've done here at user.email equals, and let's take a look at this. We want this here, equals valid address. And then we want to assert that the user is valid. So let's save that, and this should still be green, right? We're not going red here yet. So this way, if we end up implementing a pattern for the format that disallows any of these, this test will catch that. So now let's put a test in for some invalid addresses. So let's put some invalid addresses in here. Again, this isn't a proof, this is just a selection of common mistakes that people might make. So let's take a look at this. User at example com should be invalid. You should certainly have to include the @ sign. So let's catch that. You have to include the some sort of top-level domain. So example dot should fail. And then let's do foo at, this is a subtle one. Underscores are invalid in this this context. Bar underscore baz.com. So this is not a valid domain name. It's a valid subdomain, but it's not a valid domain name. And then we can do another common one. This is also illegal. This is basically to catch this plus sign because we're allowing it in the names here, in the usernames, but we want to make sure that it's not allowed here. So let's go here and do the same thing that we did here for each of these guys. Invalid addresses dot each. And let's do the same thing, just following the same pattern. And then assert that this user is not valid. Right, so I want to do assert not. Assert not at user.valid. So this should be red. Right. All right, we've gotten to red, so now this is where we have to take up the challenge and actually put a format validation in here. And so what we're going to do is something like this. We're going to say the format needs to be with, and then we're going to put in what's called a regular expression. So we need to talk about that. This is quite tricky. So let's build up the regular expression. This is the kind of thing you would definitely want to just Google around for and find a decent one. But I want to show you a really cool tool called Rubular that will give us a chance to interactively explore this regular expression. All right, so let's put in these email addresses. I'm just going to paste them in. These are the, actually let's put the valid ones in too. So this is valid email addresses and invalid ones. And let's build up the regular expression. So this is discussed in the Rails tutorial in more depth, but what I want to do is start off with at least one word character. So a word character, as you can see here, is a letter, number, or underscore. This is really helpful. Rubular has this awesome little quick reference here. So we want to start off with a word character, and we also want to allow pluses, like in here, like this here, Alice plus Bob. We want to allow hyphens, and we want to allow dots so that you can do something like first dot last here. So the way to do that in regular expression land is to use this sort of grouping. So this is a word character, \w, which you can see here. And inside these square brackets, we can use things like a plus or a dot literally. Ordinarily, these have special meanings, like over here. Where's the dot? Here's a dot is any single character ordinarily, but not inside these square brackets. But inside of these square brackets, the hyphen has a special meaning. It defines a range, so we actually have to escape it out with the backslash. Told you regular expressions are fiddly. Actually, I think I said tricky, but they're both. Okay, so that's promising. You can see that Rebreather shows us the matches over here. So what this has done is matched words, plus signs, hyphens, and dots. So we want to have this, and then we want the @ character. So you can see it's matching there. Oh, what we want is actually at least one of these things, right? So this should be one or more of those. And the way to do that is with this, the plus sign. So A plus is one or more of A, so we want one or more of these guys, followed by an @ sign. You can see over here it's just highlighted the ones that are matching. And then we want to put in at least one letter, digit, hyphen, or dot. So that's things like this. Want to match the dot so that we can do things like this foo at foo.bar.org. So at least one letter, digit, hyphen, or dot. So that's going to be a letter, A through Z, a hyphen, we have to escape it out, or dot, and we want at least one of them, so that's a plus. So after this part of the address, we need an actual dot. And you might be tempted to put just the dot character, as we did inside of the square brackets, but in fact that doesn't work because it needs to be escaped out when it's not inside these square brackets. So let's do this, backslash. You can see that there's the effect here. This is matching things like a capital C, but we want this here. There we go. And then let's see, we want at least one letter. This is something like the top-level domain. I'm actually not sure if there are any single-letter top-level domains, but there definitely are 2, 3, 4, 5, and so on. There are a bunch of new top-level domains, actually, fairly recent ones. So we're not going to reject every invalid address. We just want something that's a pretty good sanity check. So what we're going to do is say that we want at least one letter here. A through Z. Again, this A through Z here is any single character in the range A through Z. And then we want at least one of them, so do plus. And so you can see here now that, in fact, we're matching all of these valid ones, and we're not matching any of the invalid ones except for this one here. This one that has the foo.com. And that's because this A through Z here actually only matches the lowercase letters. So what we want to do is add an option here, which is /i. You can see down here, that's for case insensitive. So if you put an I in here, that should match the last one. There we go. So this regular expression matches all of the valid addresses and none of the invalid ones. Regular expressions is a huge subject, but this is a good start just to give us a sense of how to match a basic email address. So I'm going to copy this thing, and I'm going to put it in here. And anything this complicated, I'd like to give a name to. So I'm going to call it valid email regex, and I'm going to use all caps. Anytime you start the name of something in Ruby with a capital letter, like user or active record, it's actually a constant. So I could do something like this. I could start it like this, like valid email regex. But in this context where I'm going to be using the constant in regular code and not like the name of a class or anything like that, it's conventional to use all caps. So I'm going to call this valid email regex. So at this point I can just paste in that regex I had, and they go inside these slashes. That's why I put these slashes in here. We're actually going to replace that with this valid email regex. Let's paste it in. And there's actually something that I'm missing here relative to this current application. You don't need these in Rebreather. In fact, they won't work. But what we want is for this to be the beginning and end of the input string. And the way to do that, you might be tempted actually, if you've done regular expressions before, to use these characters, the caret and the $sign. You can see here. That's the start of the line and the end of the line, but that's actually not right. That's not what we want. We want the start and end of the string. So that's \A, capital A, \lowercase z. So this is \A and \lowercase z. And this is here, valid email regex. You can see the IDE let me just tab complete there. It's pretty cool. So I'm going to save it, and it should be green. But it's not. Oh, you know why? This is great. I mean, you can actually see the IDE is telling me syntax error. So if you look carefully, you can see that I'm missing a comma here. So now we should be green. Oh, and we're still red. So why is that? So okay, this is great. It's actually telling us which one is failing. It's line, where is it? It's line 36. And this is actually a useful trick. Maybe I should put this in the book. Probably will. Which is to add in an optional message here, and because actually we don't know which of these addresses failed. So we can say just save this and see which one is failing. I know which one. I mean, I've guessed which one it is, but you can say address. Here we go. And in fact, we can even do inspect. This is nice, because this will put quotes around it. Yeah, address user@foo.com should be valid. So remember that in order to get that one to be valid, this one here, we had to do the /i for case insensitive. Right. So that's what's failing here. What's failing here is that this regex here is actually case sensitive, and so let's put in the /i here. That's the way, like in Rubular, you put it in this little box here, but with a regular expression, you put it here. So let's save that. Now this should be green. All right. It's probably a good practice just to put this here in the same place here. This should be invalid address. It should be invalid. And you can see we've now spilled over the 80 columns, so I'm going to put in a new line. And actually, you know, this is the kind of thing where I might just get rid of it there. There we go. So now if we were to say allow an underscore in here, this one will fail. No, it didn't fail. Why didn't it fail? Oh, maybe it's in here. Let's put an underscore in here. There we go. So now foo@bar_baz.com failed, and the test tells us that right here. There it is. So that's useful. It tells us which one is failing, so we can fix it here. Great. Now that we've added the format validation on email addresses, there's actually only one validation left, which is the uniqueness validation. So let's write a test for that. What we want to do is make sure that there's a duplicate email address in the database, in the test database in this case. So remember, we did user.new here. This does not save the user. So one of the things we'll have to do in this test is to save the user to the test database. Let's do this, and then let's make a duplicate user that has the same values as the current user. Called the duplicate user. And there is a method for doing this called dupe. It just duplicates the values. So we can go in here and say, we can't just say duplicate user equals @user, because then they're the same object. What we want to do is make a copy. So that's what dupe does here. And then we want to save the user. Right, if we just did this, when we saved the user, it would actually save the duplicate user too, because they're the same object. So dupe fixes that problem. So then in the test, we want to save the user, and then what do we want to do? We want to say that this duplicate user, which exists only in memory, right? We have not saved this user. We want this duplicate user not to be valid. So assert not this thing valid. So assert not duplicate user, oops, why didn't that work? Dot valid. So we save this. This should fail, right? Because remember, we want to get to red for test-driven development. And let's get to green. Okay, let's take a look at this here. What we want to do is add the uniqueness validation, unique true. Save it, and we'll be green. Oops, that didn't work. Oh, uniqueness. Now we'll be green, right? All right. So we're done, right? This is it. We've solved the problem. Yay. Alas, not. There are actually a couple of things that are wrong. So let's look at the first one. Now, technically speaking, two email addresses that differ only in case are in fact different. So this, actually just do this here. So this email address, technically speaking, is different from this. But this causes all kinds of confusion, potentially, and most email systems consider these to be identical. And even if we wanted to consider them to be distinct, so many other systems consider them to be the same that this would cause terrible interoperability problems. So we're going to consider these two to be the same, and let's go back to our guard window. Again, we want to get to red first, so let's go to failing test. Let's take this duplicate user and just upcase its email address. We actually saw upcase in the context of map in lesson 4, but what this does is just upcases the email address. So does this. So this duplicate user now has the same email address except it's all uppercase, and it should still not be valid, but it will be because uniqueness true doesn't have any sort of case insensitivity. So this is red now. So the way to do this is to change this true to a hash, which is case sensitive false. So the hash is the key is case sensitive and the value is false. To turn off case sensitivity, this implicitly has uniqueness true in here, so this should work. No, it didn't though. Oh, I just did something stupid. I said duplicate user is equal to this. This is just a string. But what I want to do is assign the duplicate user email address to this. So there we go. This should work now. Great, so let's just go back here. Oops, I'm going to do this here. Get to red, and then go green, just to make sure we're testing the right thing. All right, there we go. So at this point, you think we're definitely done, right? Let's run the whole test suite. So this looks promising, and in fact, it's almost completely done. But there's one scenario that we haven't accounted for, and this is really quite tricky, so let me go through it. So the scenario is when a user, let's call her Alice, accidentally clicks twice in quick succession on the account creation button. Under certain conditions, this can create duplicate users, that is to say users with the same email address, thereby leaving the database in an invalid state. So what happens is the first click goes through and the first user object passes the validation because there is no such user in the database. Then the second click also creates a user variable that passes validation because the first user hasn't yet been saved. Then the first user gets saved, and then the second user gets saved. Because the second user already validated, the second save goes through, and you end up with duplicate email addresses. This actually happened to me on a site several years ago. This is how I learned about how to solve the problem, which is to enforce uniqueness not only with a validation in memory here in this Ruby code, but also at the database level. The way to do that is with what's called a database index. So the idea behind an index is actually not related specifically to uniqueness. It's actually designed to make finds more efficient. So let's go over to the console. And actually, my user somehow disappeared. I'm not sure how that happened, so I'm going to create a new one. User.create, let's just say name is so that created a user, and now we can do something like this. We saw this before. So this finds the user with this email address. But if you think about it, suppose there were, say, 10,000 users in the database. In order to find by a particular email address, you would, in principle, have to go through every single record in the entire database. In the database business, that's called a full table scan, and it's a potentially very costly operation in terms of computational cycles. So in order to make that fast, ordinarily what you would do is add an index. The way an index works, it's just the same idea as a book index. So for example, suppose you wanted to find the occurrence of M. Hartle in a book. Now, if you're dealing with an electronic book, you can just search through it. But with a print book, that won't work. And in principle, you would just have to go through every page and try to find where this string occurs. But of course, there's a traditional solution to this problem in the publishing industry, which is to make an index. So you would have an entry at the end of the book, and it would say that M. Hartle appears on, say, page 5, 17, 42, 121, and so on. So it would just give you the exact page numbers. A database index works basically the same way, except that we would be indexing the string. Here we'd have an index, and then it would just have the address. Essentially, it would say, well, this is ID 1. I'm actually not sure how it works internally. It probably depends on the database. But the idea is that it's the same sort of association between email addresses and where they're located in the database. And ordinarily, it would be set up essentially as a hash or something equivalent so that this is a key value pair and we wouldn't have to search through all of the different possible email addresses. So you would just be able to look up the string and it would just have the corresponding ID. Again, I'm not sure of the details, but this is the basic idea. It's very similar in spirit to the way a book index works. Since we need to manipulate the model, we're going to make a migration for this. So let's close this down. This is the first time we will have made a migration directly. The way to do it is with Rails generate migration, and then the name of the migration, which in this case I'm just going to call add index to user's email. Generates the new migration, and then we can just go to db migrate. And here it is. So this is just an empty migration, essentially. It's got the class that, I mean, this doesn't matter. This is just inheriting from active record migration, but I don't even know what this does exactly. But I do know that I can edit this change method. What I'm going to do here is use the add index method to the users table here, and then email attribute. So this would solve that efficiency problem I mentioned. This would prevent a full table scan. But the reason we're using an index in this context is because we want to prevent this uniqueness violation at the database level. And so the way to do that here is to say that the index has to be unique by giving it an option, unique, true. We save that and run the migration. Then that updates the database, and actually I should do bundle exec here, just for completeness. All right, we can look at the schema here to see what it did. All it did is it added this index right here. We can actually see the effect of this by running our test suite. Just hit return to run the whole test suite here, or we could do bundle exec reg test. And you see here, wow, 14 errors. What happened? And the answer is that Rails actually has created, as part of the Rails generate model, a file that contains sample test data inside what's called a fixture. So let's take a look at that. That's in test fixtures users.yaml. So if you look at it, there are actually a couple of things going on here. You can see that the email address is not valid, but that's okay because, in fact, the fixtures don't have to pass validations. More important in this context, though, is that the email addresses for these two records, 1 and 2, are the same. And so that's actually causing the problem, is that if you look here, it says active record not unique, SQLite 3, constraint exception. So this is actually nice. This is a feature, not a bug, in the sense that it's actually caught this problem with the database. So this is our red, right, in our red-green. The way to fix it for now is just to get rid of this. We're just going to make this whole thing empty. I'm going to put in just a comment indicating that it's empty. That's not an error. That's actually what we want. We'll be using fixtures later in this tutorial, but right now I just want to get rid of them. So what happens here is that the fixtures get loaded automatically by Rails, and as a result of the duplicate email address, it was causing the test suite to fail, but now we've gotten to green, and so the email uniqueness validation is complete. Or is it? There's actually one more thing. The issue is that some database adapters are case insensitive at the database level, so that this index we added, let's go to the migration. Some databases consider, say, user add this here is a user add example.com. Some databases consider that to be the same as this. So what we want to do is convert this first one to the second one. We'll just standardize on all lowercase. So what that means is before saving an email to the database, we want to change the case to lowercase. And the way to do that is with what's called a before save callback. So a callback is just a method that gets called at a certain point in the lifecycle of an object, in this case before save. So before we save a user, we want to make sure that the email address is lowercase. There are several ways to do this, but the easiest way at this point in the tutorial is to do this. We'll talk about this later on, but it turns out that when making an assignment like this, we have to do this self dot. Without the self dot, this would just create a local variable called email. That would not work. So self.email equals email.downcase. This is not completely idiomatically correct, and we'll talk more in this tutorial about how to fix this up. There's an exercise in chapter 6 of the Rails tutorial that improves it in one way, and then later on in the tutorial we'll actually do this in a slightly different way. But for now this is sufficient, and let's switch over to our guard tab and rerun the test suite, just to make sure we're still green. Great. By the way, if it makes you a little nervous making this kind of change without a test, that's good. It should make you nervous. And adding a test for this functionality is one of the exercises in chapter 6 of the book. At this point, we've finished the validations for the name and email attributes, so let's take another look at this mockup to get a sense of what we've done and where we're going. So at this point, we have attributes on a user model for the name and email, together with good validations for each one. So all we need to do now to have a complete backend for this kind of sign-up page is a password field with a confirmation. Almost all the functionality we need for this last section can be implemented with a single command. Let me show it to you. This is a little bit of Rails magic. This is a method called hasSecurePassword defined by the Rails framework. So let's take a look at the data model necessary to get this to work, and then I'll talk a little bit about exactly what hasSecurePassword does for us. This is the current state of the data model. We've got ID, name, email created at and updated at. So we're just going to add one extra field. We're going to add password digest. Digest here refers to the result of applying what's called a cryptographic hash function. We'll have an example of that in a moment, but the idea is that we're going to transform the password into a string that is secure, such that there's no way to infer the original password given the digest. This is just a convention in Rails. If you create a password digest attribute on a model, then HasSecurePassword will give you a whole bunch of functionality, including a pair of virtual attributes that are equivalent to doing something like this. Remember this attr_accessor that we did in lesson 4. So this HasSecurePassword line automatically creates these things for us, so we don't actually need them. I just wanted to show you basically what they are. And HasSecurePassword also creates validations on the presence of the password and the confirmation, and also requires that they match each other. Delete that. We'll also see that HasSecurePassword gives us an authenticate method that can be used to authenticate a user based on the password. In order to get this password digest attribute, we need to make a new migration, so let's do that. Let's call it add password digest to users. And then we can give it the attribute and the type. In this case, password digest and string. All right, let's take a look at that migration file. We can just do this. We can do add password. Here we are. So this is it. Add column user to the users table here. Then the attribute password digest and the type. So let's run the migration. All right, let's take a look at what actually happens when we include HasSecurePassword. So I'm going to save this and let's take a look at our test here. All right, we've got 2 failures. Let's open up the test. So which test failed? Let's see. The email validation failed, and should be valid failed. So user@example.com, this should be valid. It's kind of weird, isn't it? And also this validation here, just the basic one, user should be valid. That's also failing. So the reason that's happening is because HasSecurePassword has added these validations on password and password confirmation. In particular, this @user here is missing both a password and a confirmation. So let's give it a valid password and password confirmation. Okay, so password and password confirmation. Let's save it and see what happens. Look at that. It's green. So let's just run the whole test suite. Great. In general, it's a good idea to require some sort of basic strength of password, and there are various ways to do this in Rails, which you can find out about by looking at the Ruby on Rails tutorial book, which has a link, or just by Googling it. But we'll include a minimal requirement by actually setting a minimum length on passwords. So let's just put in a validation for a password that's at least 6 characters long. In fact, we can start off by putting in a test. See, where's our length validation? Test, let's say password should have a minimum length. And let's do user.password equals a times 5. So let's have 6 be the minimum. And we want to assert that it's not valid. So this will actually pass, which is wrong, right? Because we don't want this to pass. We want this to be red. We're supposed to get to a failing test. The reason that it's passing is because in fact, the @user is not valid. And the reason it's not valid is because the password and password confirmation have to match. But we've just changed the password, so we also need to change the confirmation. So we could do this. We could do this, just set this equal to the same thing. This will get us to red. But there's a more compact way to do it, which is by just putting both of these assignments in the same line. There we go. So this is failing as required. Let's put in the validation. It's the same thing as validates name. Let's just do this. Just copy it. So it validates password, and present is already implemented by virtue of has secure password. We haven't written tests for that because has secure password is part of Rails itself. So there's really no need to add a test for it. But in this case, we do want to say that the length should be a minimum of 6. All right, so now that we have that validation, a password of length 5 is invalid, and so assert not @user.valid is true, and this is now passing. So let's run the whole test suite. Great. As a final step, I actually want to create a user in the actual database. That means starting a console, not in a sandbox. So let's do that. Just Rails console by itself. And we'll also get a chance to take a look at some of the methods that has secure password gives us. So let's use the user.create method. Oops, I need to put this in a string here. You can use either single quotes or double quotes when making your strings, but you can't mix them. At least not in the same string. Okay, so this should work. There we go. So let's take a look at the actual database. This is it's in DB development. So let's right click and download this. So let's see, remember I moved it here. And oops, that's right. Okay, so here we are. Move the downloads to right. So this is right. This should just work. It'll probably ask me. Oh, it didn't. That's surprising. Oh, no, I did the same thing. Well, I can just up arrow. I used the SQLite 3 too. All right, well, up arrow wins. Okay. So, yeah, there we are. All right, let's open up the development.sqlite 3 database. So I just downloaded that from Cloud9, but now we can take a look at our users. So we've got the structure. This is the database structure, though, here you see, and now I want to browse the data. And so this is the default table. It shows me the schema migrations, which just keeps track of the migrations. So let's look at users, and there it is. Take a look. Oh, look at that. It actually created, I don't know how that happened. When did that happen? That's weird. All right, well, let me show you how to recover from this kind of weirdness. I'm just going to delete this thing here. Yeah, will this work? Yeah. So let's go to a different terminal. Let's just open a new one. The entire database in this case lives inside of that one file, so we can just remove it. So that removed it, and now I can just create it again. Oh, actually, you know what? That might not work. Yeah, there's something weird going on. So I should shut this down. I should get out of the console. And one of the things I need to do is to create the database by migrating again. All right, so now let's fire up the console again. And I can actually up arrow. That's pretty cool. All right, let's try that again. Actually, let me do this. Okay, user.first is right, so let's download this again. And I get another chance to get this right. There we go, SQLite 3. It should ask me, do I want to overwrite it? There it is. Okay, let's take a look at this. And maybe refresh it. Probably just select one, select the other. Nope. Just restart it. There we go. This will work. There we go. Okay. So now it's just that one record, as I expected. And here are the columns. So this is the password digest. You can see this is a pretty complicated looking string. We can go over here and say user.password digest. Oop, I don't actually have a user though, do I? So let's do this here. User equals user.first. Now this should work. Good. So this is what a hashed string looks like when we're using, or a hashed password when we're using hash secure password. I mean, it's just a hash string. The string happens to be a password in this case. In case you're curious, what we're using in this case via hash secure password to do this one-way hashing is called bcrypt. It's a very good security library, and among other things, if you're really into this sort of thing, you might be worried whether this hash is salted, and the answer is yes. If that doesn't mean anything to you, don't worry too much about it. It just means that if you hash the same password twice using the same bcrypt algorithm, that the digest will be different. So that means in particular, if two users have identical passwords, their password digest will still be distinct. So one of the things that hash secure password does for us is it gives us an authenticate method on the models, in this case the user model. And what you do with authenticate is you give it a password. So I can just type in some stuff. And this should return false. Remember, the password is actually foobar. So let's do something that's close, but not quite. Still false. But user.authenticate with the right password returns the user. In particular, in a Boolean context, remember we can do bang bang. It's true because the user object is not nil or false. In a Boolean context, user.authenticate of the right password is true. So you can see that with hash secure password, not only do we now have the back end for this sort of sign in or sign up form, but also when users try to log in, we'll be able to authenticate them based on their submitted passwords using authenticate. And that's it. We're now done with the basic user model. So let's run our test suite and add all the new files, make a git commit, and deploy it to production. I can just hit return here. There we go. So our test suite is green. Add all these files. And then we can merge into the master branch. There we are, and let's push it up to Bitbucket. And we can also deploy to Heroku. At this point, I really do think it's a good idea to rerun the test suite. In this case, we haven't actually made any changes to the master branch, or like no one else has made any changes. But in real life, sometimes you'll have changes to the master branch that other people have made where you pull in the changes. So it could easily break the test suite, especially after we just merged in a branch. So let's run the test suite one more time. All right, the test suite is green, as I was very confident it would be. And so let's push it up to Heroku. All right, at this point we need to run the migration at Heroku, so that's Heroku run. RakeDB migrate. We can verify that that worked by running a console on Heroku. So let's do user.create. Oh, you know what? I think I want to do this in a sandbox. It doesn't really matter, but I think it's a good idea. And it's good to see that you can do this on Heroku too. We'll do a first sign up through the web in the next lesson, but I don't want to create any users at this point. Okay, user.create. There we go. This is now using the production database at Heroku, which is PostgreSQL. We can do all the same things we did before. User.first. In fact, let's scroll up. Can we see it? Here's the first part of the digest. Just copy that. It's not complete, but it'll give you an idea. Here we've got user.first.password digest. And you can see that they're different. Even though the password was the same, even though I used foobar for both of the passwords. Because of the salting, they're distinct. So where was that? Yeah, here it is. So it's the same password, but a different hash, a different digest. I should mention that sometimes this password digest is referred to as an encrypted password, and that is the wrong terminology. I actually used this terminology before, but it's wrong because encryption implies decryption. If you can encrypt something, that means you can decrypt it. But the whole point of this thing here, this hash, and we'll be talking more about this in later lessons, is that it's irreversible. There is no way to figure out from this hash, or rather this hash, what the password is. It's computationally intractable. It would take more than all of the computers in the world running for the entire history of the universe to invert this thing and turn it into the original password. So at this point, we have all of the elements we need to actually write this working sign-up form, which is the task of the next lesson.